was ready to go in.
Starting to record. All right, go ahead.
Oh,
Let's say that I've got my magnet, okay? And let's say I've got my copper disc. Okay. So there's the pole of the magnet. Okay. The magnetic lines of force are going to do this, right?
damn, you'd be good at Gartic phone, bro. Sorry.
Okay. So imagine all of these magnetic lines of force as like guitar strings, okay? If I spin the magnet, relativists would expect the guitar strings, there's infinitely many of them, by the way, but I've just drawn an approximation. A relativist would expect the guitar strings, since they're attached to the surface of the magnet, to spin with the magnet. Now, of course, if the guitar strings rub against the copper disc, right? If they rub against the copper disc, you're going to hear a note play. Okay. So in the case of the Faraday paradox, when you spin the copper disc, of course, you've got a bunch of guitar strings sitting there, right? Imagine just a fixed web of guitar strings that are just taut, right? They're just ready to be plucked. If I spin the copper disc and rub the edge of it against the edge of the guitar strings, all the guitar strings are going to hum. If I spin the if I keep the copper disc in place and I spin the magnet and the guitar strings are fixed to the magnet, I would also expect the same thing to happen because it's equivalent. But that's not what happens. When you spin the magnet, nothing happens. You hear no sound. There's no induction that takes place. So when I talk about cutting the magnetic lines of force, if there's relative motion between the two, they should cut the lines of force. That's the plucking of the guitar strings. So you can just
Oh,
think of the, yeah,
dude, thank you. That makes so much sense. That gives so much context to what was being talked about.
yeah, that's it. It's a pretty basic illustration. You get it
Yeah,
now.
no, dude, absolutely.
Sweet. All right.